right, you guys are going to need this note sheet that we've been working on for several days, and you are going to need worksheet D from topic 1.5. So we're going to do one of these problems as an example also. All right, so to finish this up, we're going to talk about how we can use a table of values to find the degree and talk about even and odd functions. All right, so we have already done this a little bit whenever we were talking about linear and quadratic, but for any polynomial function, we can use a table of values to figure out the degree. So if the given table of values with equal length input value intervals, so you guys probably are used to hearing those words, but these have to be changing by the same amount for this to work. Otherwise, it won't work out evenly. So we can determine the degree of the polynomial by examining successive differences in the outputs. The number of successive differences needed for the differences to be constant is equal to the degree n of the polynomial. So when we did this before, if the first differences were constant, then it was linear. That's a degree 1. If the second differences were constant, it was quadratic. That's degree 2. But we can also do this for cubic and for quartic, as long as there are equal length input value intervals. All right, so there are equal length input value intervals for example 6A and B. And so I'm going to just find the differences by either taking one and subtracting the previous one from it, or just thinking about how much it changed. It doesn't matter. Either way, that's going to be -1, and then 2, 5, and 8. All right, not constant, so not linear. So now we'll go and find the differences in those, the second differences. So if you think about how much this changed from -1 to 2, that's going to be 3. Or you could do 2 minus -1 or 2 plus 1, which is 3, whichever way you want to do it. But we do get that the second differences are constant. So this is degree 2. Or if you wanted to go further, you could say it's a quadratic function. All right, let's look at the next one. So find how much it's changing, or subtract 1 minus the previous one. So not linear, not quadratic, but looks like the third differences are constant. So it is degree 3. Or if you want to go further, you could say it's a cubic function. All right. Now, there are special functions that are called even and odd function. And this isn't just like this even degree or odd degree. It's actual just even function, just odd function. All right, so for an even function is going to be symmetric over the y-axis, and that's pretty easy to see. So if you can fold it on the y-axis, it folds on top of itself, it's even. So this is an example. This side of the graph can be folded right on top of this side. That's the even function. Also, one thing that we need to check is that if we put in the opposite of x, we find that f of the opposite of x is the same as f of x. Let me show you what that looks like on the table. All right, so I'm just going to have a table of values I'm going to fill in. So whenever I look when x is -3, the value of the function is 2. So if this was an even function, then f of +3 should also be 2. So let's see that if that happens when x is +3, y is also 2. right? And that should work for the whole function. So f of negative 2 looks like it's negative 3, and f of positive 2 is also negative 3. Right, negative 1 is negative 1, positive 1 is negative 1. 0 is, I don't know what, I'll say 1/4. There's not an opposite of 0, so we don't really have to worry about it when we're thinking about even and odd. Right, so that's even. And then there's an example of an even function. If it is a polynomial function, then it would need to have only even powers, including x to the 0. All right, and then odd function is symmetric about the origin, which is not a symmetry you're probably super used to, but symmetric about the origin is this. It's almost like it gets reflected on the x and the y, and it ends up being this. Or you can think it's rotated around 180 degrees, but that's what origin symmetry looks like. And for origin symmetry or odd functions, whenever you put in the opposite of the x value, you're going to get the opposite of the y value. And I'll show you what that looks like with a table of values. All right, so I'm going to use the same values as the previous. All right, and then when I look at, well, this isn't a great one, but f of negative 3 is 0. There is no opposite of 0, so f of positive 3 should be the same, so that's not a great one, but let's look at 2. So f of negative 2 looks like it's 2. So f of positive 2 should be the opposite of that, and it is. It's negative 2. Right? F of negative 1 looks like it is about, we'll say about 1.5. F of positive 1 is the opposite of that. And f of 0 is 0 again. All right, and then for the algebraic form, for looking at it, there should only be odd powers. It cannot have a constant. If it has a constant, it messes it up because the constant is an even power. All right, so on example 7, we are going to algebraically decide if these are even, odd, or neither. And so I'm just going to put in negative 1. So negative 1 to the 4th is just 1, so that's 2 times 1. Negative 1 to the 2nd is also 1. All right, and that's going to give you 6. Now, if this is odd, I would get negative 6. If this is even, I should get 6 again. All right. So because they're the same, this is an even function. All right, we'll do the same thing on B. I'll put in negative 1 for x. So negative 1 cubed is negative 1. And then 3 times negative 1 is minus 3. All right, so if this was even, I would get negative 5. If this is odd, I would get positive 5. But I don't. I get 3. So in this case, it's going to be neither. Then on C, we can look at the symmetry, and this is exactly what symmetric about the origin looks like, but we can double check with a point if you wanted to. We could do our whole, I don't know what this is, we'll call it F. We'll do -1 again. So f of -1 is 3. F of +1 is -3. That's odd. Right. And then on this one, we can tell there is not symmetric about the origin, and there's no symmetry on the y-axis. There is symmetry, but the axis is over at x equals 1. We need it to be at x equals 0. So this one is definitely going to be neither. If you wanted to show it algebraically, we could do f of -1 is 1, f of +1 is -3. So that's definitely a neither situation. All right, we're finally finished with this massive note sheet, but we're going to do one more example on your worksheet, D. We're going to do number 7. This is kind of a creative way to test your knowledge about even and odd functions, but we're going to say this is an odd function, and it is strictly increasing. Selected values of g are given in the table above. We're going to find the constants a, b, and c. All right, so here we go. This one has a, and this value is -17. If it's an odd function, we're going to need to be looking for +17. So if this is -12, we get -17. If it's +12, we get +17. That's what happens on an odd function. All right, and let's find b. So here's b. All right, this is 11, so we're going to look for -11. So this needs to be the opposite of that value. So b is going to be 4. All right, now to figure out c, we're looking at these blocks right here. So if this is -1 and this is 1, this needs to be the opposite of whatever that is. So to figure that out, we would add a and b. So -12 plus 4 is -8. So that's going to make c +8. All right, so your assignment is to complete the rest of worksheet D.